When you hit send on a text in a crowded coffee shop, it feels like your phone is instantly reaching out across the world. But your device isn't actually touching the global internet at all. It's operating inside a closed, isolated loop called a local area network, or LAN. If we look at this network breakdown, your phone is what's known as an end device. To talk to anything else, it has to pass its data through intermediary devices, like the switches and routers physically located inside that exact same building. Talking to another laptop on that local Wi-Fi network is fast and seamless, but the moment your data tries to leave that bubble and head out to the wider world, it hits a massive structural wall. To coordinate traffic inside this bubble, a hidden DHCP server hands your phone a temporary local identity, a private IP address. The problem: private IPs are strictly forbidden from the public internet. If a packet crosses the boundary with that label, it physically bounces right back. Without a way to change its digital name tag, your message is mathematically trapped inside the physical walls of the cafe. With millions of devices hitting this exact same wall every second, the modern web relies on a highly specific escape hatch to let that data out. Your phone's operating system knows it can't cross the border alone, so it automatically looks for a designated exit point, known as the default gateway. Looking at this network topology diagram, you can see that gateway is usually a physical router at the edge of the network. Take router 2, right here in the center. It physically bridges the gap between separate, isolated local networks. But knowing where the exit door is located doesn't solve the problem. To actually survive the physical journey to the router, your data requires a clever dual packaging system. This table details the dual packaging. The inner packet holds the ultimate destination IT. It sits inside an outer frame that uses a MAC address to guide data point to point. Notice the outer frame is rewritten at every stop, but the inner packet remains completely unchanged. This two-envelope handoff ensures that your private data is successfully delivered right to the feet of the router, prepped and ready for processing. The moment that packet is handed to the router, the gateway inspects the delivery and immediately flags the unroutable private source IP address on the envelope. To fix this, the router initiates Network Address Translation, or NAT. It acts as a digital translator, stripping your device's private identity off the packet and logging it into an internal ledger. It then attaches its own public IP address before firing the data out. It operates exactly like a corporate mailroom. It takes a letter from an internal cubicle, swaps it for the building's public street address, and hands it to the post office so they know where to return the reply. Network address translation is the invisible mechanism that makes your isolated local network mathematically compatible with the entire global internet. This creates a massive, powerful scaling advantage. Because of NAT, an entire crowded building of smartphones and laptops can funnel smoothly out to the internet through just one single public IP address. When a website sends data back, the router consults its ledger, remembers exactly which private device requested the information, and routes the packet back through the maze to your specific screen. This also creates an inherent security wall. Because your private IP is stripped away at the border, your phone is hidden and cannot be directly targeted by external internet traffic. Without routers acting as these border guards and translators, the world would have run out of usable IP addresses decades ago. You can actually find the exact border guard for your local connection right now. All you need to do is open up the command prompt on your computer. Typing ipconfig exposes your network's hidden architecture. At the bottom is the default gateway IP address. As the instructions show, sending a ping command to that address verifies if your computer can successfully reach the edge of its local bubble. Every fast-loading video and instantly delivered text you send is a quiet triumph of routing. Your devices can't talk to the world on their own. They rely entirely on the gateways that speak for them.